Okay, so we're going to start our last full chapter, which is chapter 12. It's all about volume and surface area of 3D shapes. Some of the shapes we study will be polyhedrons, some won't be. Okay, so the first shape we're going to study is a prism. Okay, now when you mention prism to somebody, a lot of people have kind of a generic picture in mind when they think of a prism. But there's all kinds of prisms. Okay, a prism is basically, it has to be a polyhedron, and it has to have two congruent faces that we call the bases. Okay, the bases could be squares. Okay, that would make it a rectangular prism, or it could be a cube. The bases could be triangles, so it could look kind of like a tent. Imagine that, two sides of a tent, triangular. Okay, so the two faces that are congruent, those are called your bases. All the other faces are called lateral faces. Okay, they're the other sides. Okay, so once you mark off what your bases are, everything else is a lateral face. Now, if you had a rectangular prism, there's a lot of ways you could look at the bases on here. Okay, we could say that if we had a book, the front of the book and the back of the book, those are my bases. Okay, so the book would be like that. Every other side is a lateral face. Okay? Or you could stand a book upright, and you could say the bottom face is a rectangle, the top face is a rectangle, and they're congruent. So now this is my prism standing up. Every other face now would be a lateral face. Besides rectangular prisms, most of the time you can only put the prism one way and have it be on its base. Okay? Rectangular prisms are kind of special. Okay. All the lateral faces are parallelograms. Okay? And this kind of helps me when I have to do sketches. If you want to sketch a prism, all you have to do is draw two shapes that are congruent, okay? Space them apart a little bit, and connect corresponding vertices. Let me show you an example. Let's say you had this and this. And you want to make that into a prism. Okay, all you have to do is connect corresponding vertices. Okay, lower right to lower right. Upper right to upper right. Connect the lower left, whoops, to lower left, and connect upper left to upper left. If you connect corresponding vertices, boom, you just created a prism. And you can do that with any two base shapes as long as they are congruent. I messed that one up. But there's another prism. That'd be a triangular prism. Okay, all of the edges that I just drew in, okay, the edges that connect the bases, those are called lateral edges, okay, because they make up the lateral faces. So here's another prism. Okay, since I drew in all these 90-degree angles, that makes it a rectangular prism. Okay. This edge in red is a lateral edge. Okay. So is this other edge on the left, this dotted one in the back, and this one on the right. Those are the four edges that connect the two bases. Okay. And where that black arrow is pointing, on the right side, that's a lateral face. So is the front, the left, and the back. Those are all lateral faces. Okay, top and bottom, that's your base. Any questions on any of those terms? Okay, we kind of talked about some of this in 12.1 with faces and edges. We're just being a little bit more specific. It's a lateral face or a lateral edge. Okay, does everyone have that diagram? No. Okay, one thing they might ask you to find is the height, okay, or we also call it the altitude of a prism. Okay. Basically, all that is the distance between the bases. Okay, the distance between the bases. So in this picture, from here to here, that's the height of my prism. It's not how high, if you put this on a table, like how high up off the table it would be. Okay, unless you have it standing on its base. Okay, so if I'm thinking this is a base, and this is a base, that's my altitude. Okay? But in a rectangular prism, you could also do this. You could say, this is a base, this is a base, and that's not. Okay. Now, if those are your two bases, the altitude here is the distance between bases. Okay, so whatever you call your bases, the distance between them is the altitude. This part, it's just going into more detail about prisms. You don't have to know that part. Okay, let me just show you the picture. Okay, it's possible you could have a prism that's kind of like bent a little bit. Imagine the bottom was stuck in place, and this was kind of rubbery, and somebody just took the top and pushed it. Well, what would happen then is all of a sudden all your angles would they wouldn't stay 90 anymore. Okay, they'd all become a little bit skewed. All right? Kind of think of it, it's almost like a rhombus, except in 3D. Okay. In this case, when you start to take it and skew that shape, the slant height is a diagonal height. Okay? The regular height would still be this. Basically, if somebody was standing on the top right here, dropped something off the top, and it fell straight down, that's the height of the prism. Okay? The slant height is kind of that height going up the side. We're going to see that idea when we talk about pyramids. Okay? Imagine this is like the cross-section of a pyramid. Okay? If you were standing at the top and there was a hole in the pyramid, and you drop something straight down to the floor, right in the middle of the pyramid, that's the height. Well, let's say there were also some stairs on the side of the pyramid that you could walk up. That's the slant height, okay? Walking up the side of the pyramid. Which one do you think is shorter? The height or the slant height? Yeah, the height, definitely in a pyramid, the height is always shorter. It's falling from the top straight down, okay, rather than going at an angle down. Okay, so that's an important word to understand the difference between height, slant height. Okay, any question on that? Okay, and this shape right here, this is called an oblique rectangular prism. What do you think when you make it oblique, okay, by kind of bending that top side? Do you think it changes the volume? What do you think, Luke?
I don't know anymore. Bigger.
Not sure? Anybody, what do you think?
Oh, the volume?
Yeah, do you think you could fit more or less stuff in here now when you start to bend that shape?
It should stay the same.
Stay the same? All right, we'll think about that when we get to volume. Maybe we'll try to look at that. If you bend that shape, does it change the volume? Okay, or does it change the surface area? Okay. We'll talk about that when we get to it. Okay, prisms are classified by their base. If the base is rectangular, called a rectangular prism. If the base is triangular, triangular prism. If the base is a hexagon, hexagonal prism. Okay, so whatever the shape of the base is, that's how you classify it. Okay, surface area. Okay, so this is what we're going to be studying for the two shapes we do today. Surface area basically is if you were building the shape, how much material would you need to build the sides of the shape? Okay? So the surface area is the sum of the areas of every side. What do you think the lateral area would include? If the surface area is the area of all the sides, lateral area is not going to be all the sides. It's going to be all the sides except for what?
1, 2.
Except for two sides. Which two sides?
Bottom and top.
Yeah, your bases. Okay? So if they ask you on MCAS and they have a special section on your reference sheet, they have a section for surface area, they have a section for lateral surface area. If they say surface area, they want you to find the surface area of all the sides. If they write lateral, find the surface area of all the sides except the bases. Just the lateral faces. Okay, so ignore the bases. All right, so let's try an example. Okay, here we have a right rectangular prism. It says the height is 8, the length is 3, and the width is 5. Okay, those are our dimensions. So if we want to find the surface area of this shape, we should try to break it down. Okay, break it down into sides. Okay, let's pretend that the way it's standing, it's on its base. So the top is a base, the bottom is a base. What shape are my bases here? Don't go by how they look, make sure you look at the numbers. Okay, the bases here are rectangles. And Kira, how does the top base and the bottom base compare? They're exactly the same. You've got two of them, right? So if we can remember how we find the area of a rectangle, find the top, and then the bottom's the same. Just double it. Okay, so Ariel, what's the formula for area of a rectangle? Yeah, how do we usually say it though? Rectangle, we usually say length times width, yeah. That same idea. Length times height, length times width. All right, so take length times width. That's going to give you the area of the top and bottom. Okay, so let's do top and bottom. First, I'm just going to put a 2 in front because I'm going to double whatever I get for the top to get the bottom. Okay, so the top is 3 by 5. So it's going to give me 15. Doubled is 30. Okay, so that's the top and bottom. Okay, now let's do the front and back. Okay, front and back, again, you've got two of them. What are the dimensions of the front rectangle? Denver?
3.
Yep. 3 by 8. Okay, so we have one in the front, one in the back. So that's going to give me 24 doubled, 48. So we got the top, we got the bottom, we got the front and back. We need left and right. And if you're wondering, is there a faster way to do this than adding up all the sides like this? Yeah, there is. Okay. But if you forget how to do it, you can always go back and just do it this way and it works. Luke, what's the dimension of this rectangle on the right?
5 and 8.
Yep. It's 5 times 8. We also have one on the left. It's also 5 by 8. So we can get 40. Doubled is 80. Now add up those three numbers. So we got 30 plus 48 plus 80. That's the surface area of this box. 158. Okay, and I should label all these square inches, okay, because we're finding area. So the total is 158 square inches. Now, if you just wanted the lateral surface area, take away the top and bottom base, and you can have that as well. But that's the total, 158. Questions on that? All right. Now this part's kind of visual. Okay, you might have you might have done something like this before. But basically, if you take a 3D shape and kind of cut it along some of its seams and then unroll it and flatten it out, okay, that shape you get is called a net. And there's different ways you can do it sometimes. Right? For this is a prism with hexagonal bases. And if you take and cut it, okay, just right, along its edges, you can unfold it, flatten it out. This shape right here is a net. What I've marked in H, this was the original height of the prism, once you flatten it out. Okay, any question on that idea? That's called a net. So what they might do, you might see it on like SATs or on MCAS, they might give you a shape and say, if you cut it and unfolded it, give you 4 choices. Which one could it be? Okay. A cylinder would look a lot like this one. Okay. Cylinder would look pretty much just like this. Okay. You'd have to leave it attached a little bit, otherwise you'd detach the circle from the rectangle that would be the side of the wall. All right. So in this particular net, okay, notice if you just wanted the lateral surface area, that's just this part right here. It's just a rectangle. Okay, just a rectangle. And that's true for every single prism. The lateral surface area is just a rectangle. How many sides does it have? Well, that depends on what kind of prism it is. If it's a rectangular prism, you'd only have 4 of these strips. And then you'd have a square attached to one on the top and a square attached to one on the bottom. Same one. Okay? Any questions on that? Does everyone see how this is the perimeter of the base? 1, 2, 3, 4, 5, 6. Those 6 segments I just drew are those, if you folded it back up and reconnected it. All right, so all you have to do is take your perimeter of the base, multiply by the height, and that gives you the area of that rectangle, which is the lateral surface area. Okay, so that's kind of a shortcut. This part is what I just went over with you. Take the perimeter of the base times the height. This is the lateral surface area. What's this part? Well, B is the area of the base. And if you take the area of the base and double it, because you have 2, add that to the rectangular part, which is the side, that gives you the total surface area of a right prism. Right? So double the area of the base, plus take the perimeter, multiply by the height. And that will give you the surface area of a right prism. S is surface area, B is the area of the base, P is perimeter, H is the height. H, that's simple. Height, it's not too hard. Perimeter of the base, that's usually pretty easy. B can be difficult. Okay, the reason B can be kind of tough is if I gave you a shape like this, I don't think anybody knows the formula for the area of a hexagon. Okay? So as we go through the homework problems, I tried to pick out prisms that you knew the area of the base. Okay, you could find it. If you come across one in the homework and the shape of the base is a shape you've never found the area of, like a hexagon or an octagon, something like that, you're going to have to look that formula up. Okay, most of them I tried to not do. Okay, but it's not hard. The formula for the area of a hexagon, it's a super easy formula. Just most people don't memorize it. So you'd have to look it up. Okay. All these area formulas are in your book in chapter 11. Okay, we're going to skip over chapter 11. But that's where they are. So if you find a shape you can't figure out the area of it, chapter 11 will have it. Chapter 11 will also have the basic ones too. Area of a square, area of a triangle, stuff like that. Okay, so let's take this. We'll find the surface area, but this time we're going to use use a shortcut. Okay, let's call this the base, and let's call this top side the base. So I tried to shade in the two bases. So surface area, 2 times the area of the base, plus the perimeter of the base, times the height. Okay, Sarah, what's the area of my base here? Yep, that's the length of it. And that's the width, so what's the area? 50, good. Okay, so area of the base is 50. Okay, how about the perimeter? Oh, Alyssa, what's the perimeter of the base? Good, 30. It's 10, 10, 5, and 5. Okay. And lastly, the height, that's the distance between the bases, is 6. Okay. There's your shortcut to finding the surface area. If you forget this formula, that's okay. Go back and do it the long way. You can get the same answer. 2 times 50 is 100. 30 times 6 is 180. And the surface area, 280 square inches. Much faster than the way we did it before. Okay? And it all relates to that idea of cutting this apart and unfolding it and looking at it that way. Okay? Some people have a hard time visualizing that, but. Okay, so here's one that you would have a little trouble with. Okay? This is the one that's a, well, actually, somebody tell me, what's the name of this shape? Triangular prism. Is it on its base? Yes or no?
No.
No. Its bases are the front and the back. Okay, front and the back. Okay, bases are the two shapes that are congruent. So it's not kind of on its side. It's not on its base. Here's a formula that's in chapter 11. Each base is an equilateral triangle, 7, 7, 7. Okay. The only problem here is if you know all the sides, how are you going to find the area of the triangle? Well, you use this formula. Okay. So to find the area of an equilateral triangle, take the length of a side and square it. Multiply by the square root of 3 and divide by 4. Okay, so that's fair game for a question now. If I ask you, you should know that formula, or just put it on a reference sheet. Okay, so let's find the area of the base. And then once we have the area of the base, we'll double it, get the front and back, then we'll add the perimeter of the base times the height. Okay, Jacob, what's the length of each side of my equilateral triangle? Yep. Okay, it looks kind of hard, but that's all you got to do. 49 times the square root of 3 divided by 4. Okay, so we get 21.22. Okay, now don't forget, you got to double it because you have a front and a back. Okay, SA stands for surface area. Plus, now we need to add up the sides. Okay. So we'll take our perimeter of our base, which is 7, 7, and 7, times the height, which is the distance between the bases. This formula will work for any prism shape. It won't work for a cone. It won't work for a pyramid. Okay, so let's add it all up. So you get 42.44 plus 21 times 5 is 105. That's the surface area. Don't forget to put a label of square meters. All right, so that's the one that's tricky, but I tried to help you guys out with a formula. You don't have to write all these down because I think some of them you already know. They're all in your book. But if you wanted to find the formula for the area of an isosceles triangle, well, it's 1/2 base times height. Or you can also use this formula. Okay? Some of these formulas start to get really crazy, really hard to memorize, but it would work. Okay? In this formula on the right, you have to know the length of one of the legs of your isosceles triangle, and you need to know the height of it. So in other words, you'd need to know one of the legs I marked and the height. If you fill those two things in the formula, you could find the area. Okay? Kind of a weird formula. Honestly, I usually don't use that one. Okay, this is the formula for the area of a hexagon. Okay, so if you come across any hexagon bases in the homework, this is how you find the area of them. Okay, so there's your hexagon. All you need is the length of one of the sides. Square it, multiply by 3, times the square root of 3, divide by 2. How do you get this formula? You don't have to worry about it. Okay, all you have to know is what the formula is. And I think that's the only other special base I'm going to give you. Okay, and the whole reason I'm giving you these formulas is because to find the surface area, you've got to do 2 times the area of the base. If you can't get the area of the base, you can't use this formula. I don't need to give you anything special for perimeter. Okay, perimeter, just add up all the sides. So if you know one side is 3, 3, 6, 9, 12, 15, 18. Perimeter is 18. Okay. And the height, they'll have to give you that in the problem. The height would be the distance between the two bases. Okay. But B is the tricky one to find. Okay. Any questions on that? Okay, so make sure you have at least that one and the one for an equilateral triangle. All right, so let's finish up with cylinder. Luckily, if you understand prism, cylinder is pretty much the same thing, except I can tell you what the area of the base is always going to be, the formula. Okay? Because think about a cylinder. Okay? Shape of the base never changes. What's the shape of the base all the time in a cylinder?
Circle.
Circle. Okay? In a prism, I can't tell you what the shape is. Could be a rectangle, could be a triangle, could be a hexagon. I don't know. Okay, but they always have circular bases. Okay? Height, still the distance between the two bases, so you don't even need to copy that over. It's the same as a prism. Okay, the radius of the base is the same as the radius of the cylinder. So if I ask you, what's the radius of the cylinder, just tell me what the radius of the base is. Okay, it's the same thing. Okay, and the kind of cylinders we're going to look at, you don't have to copy this part down. We're going to look at right cylinders. Okay? That's where the cylinder is perfectly straight. An oblique cylinder, you can kind of imagine the base is stuck, and somebody took the top and bent it sideways. Okay, so now it looked kind of skewed.
Who did that?
Okay? Now, who would do that? All right, so there's a right cylinder. There's your height, distance between the bases. There's your radius. And you have a base and a base. Okay? You can still use the same formula I just gave you in the last part to find the surface area of this cylinder. Except you should always know the base formula because it never changes. It's the area of a circle. Okay. What is the curved surface? If you took a cylinder and you cut it kind of right up the side and you cut the top and bottom lid off and unfolded it, what shape would you have? Yeah. Okay, here's your cylinder. Okay, take a piece of paper, cut it right up the side, cut the top and bottom lid off. There's your lateral surface area. Okay, it's a rectangle. Now, originally, okay, here's my cylinder. When I cut it open, this side was the height of the cylinder, okay, the right side. How about the length of this rectangle? If I make it back into a cylinder, what's the length of that rectangle? No, not the diameter, not the distance across. It's the distance around that circle.
Circumference.
It's the circumference. Right? So if you have a cylinder, you cut it open, all of a sudden your circumference becomes the length of the top of the rectangle. And that's what that's saying right there. Okay? If you take the circumference times the height, that would give you the area of this rectangular shape, which is the walls of the cylinder. Now, that previous part just gives you your lateral surface area, okay? Just the walls. We just said that the top and bottom shape are circles. How many circles do you have in a cylinder for your bases? About 10? How many circles you got? Two. Okay. So once you find the area of the wall, you got to add the area of a circle, and then double it for the other circle. The only question: what's the formula for the area of a circle?
R squared.
Pi r squared. Yep. Okay, so to find the surface area of a cylinder, same formula as for a pyramid. Double the area of the base plus the perimeter times the height. There's your shortcut. The only thing is, I can guarantee you what the shape of the base is. It's always a circle. The area of a circle is always pi r squared. What's the perimeter of the base? Well, again, I can be a little more specific. It's always a circle. Circumference of a circle is 2 pi r. So if you substitute those two things in, you get 2 pi r squared plus 2 pi r h. B is the area of the base. P is the perimeter. Okay. When I think of these formulas, honestly, I only remember what's on the left. Double the area of the base plus perimeter times height. And then in my head, I figure out what's the formula for the area of the base for the shape I'm working with. That you have to memorize or use a reference sheet. The reason I memorize what's on the left is because I think it gets too confusing once you start learning all these formulas to try to remember everything. Try to remember the generic formula, and then you can use it on every shape. So I would try to remember double the area of the base plus perimeter times height. Okay, any question before we finish up finding a couple surface area problems? All right. Okay, so here's a cylinder. I want you to find the surface area. Okay, before I even find it, can somebody just remind me, what's my formula for the surface area of a cylinder? You don't have to be specific. You can just give me the general one. What's my formula? Well, Brian, can you start me off? Just the kind of that generic version?
2 times A plus B times A.
Yep. Double the area of your base plus your perimeter times your height. Okay, now find all those things. Okay, first thing I need is the area of the base. Okay, base here is a circle. So now in our head, we got to think, okay, area of a circle. Okay. Luke, what's the formula for the area of a circle?
2 pi r squared.
Just one of the bases. I don't need to do both
Pi
yet.
r squared.
Just pi r squared. Radius here is 3. Be careful if they give you the diameter. If they give you the diameter, what do you do to change it to the radius? Yep.
Put it in half.
Take half of it. Okay, some people mess that up. Okay, so radius is 3 squared times pi. All right, plus the perimeter times the height. Okay. I need the perimeter of a circle. Okay, what's the formula for the perimeter of a circle? Oh, Katrina? So we just had that on the previous page. Yep. Just 2 pi r. Okay, so this is your area. This is your circumference. Circumference is 2 pi r. Okay, in this case, our radius is 3. So 2 times pi times 3. Okay, and she also gave me the last part. We're going to multiply by the height, which is 4 feet. Okay, so this first part, 3 squared is 9. 9 times 2 gives me 18. And a lot of times, they're going to leave the answer in terms of pi. It's 18 times pi, plus 2 times 3 is 6. 6 times 4 is 24. 24 and 18 is 42. Okay, that's the surface area, 42 pi. If they wanted a decimal, how would you change 42 pi to a decimal? What does 42 pi mean to do? Multiply by what? 3.14. Yeah. Okay, on MCAS, they will want it as a decimal. So take 45 times 3.14. It's about 131.88. Okay, on a test, if the directions don't say how to leave it, I don't care if you leave it in terms of pi. That's fine. Any questions on that one? All right, so let's just see if we can set this up because they didn't give us a picture. Okay, it says to find the height. Okay, the radius is 6.5, surface area is 529.19. Okay, Connor, what's the formula for my surface area again? For a cylinder?
2 pi r squared.
So that's good. Double the area of the base plus, yep, perimeter, which is 2 pi r times the height. Okay. Fill in everything we know. Okay. We know the radius, so we're going to fill that in. We know the surface area. 2, that's a number. Pi, that's a number. 2's a number. Pi's a number. H is the only thing we don't know. Okay. So we just have to solve for it. What's 2 times 3.14? Let's do that out.
6.28.
Yep, 6.28. Okay, my radius is 6.5. Probably need a calculator to square that. 42.25. Plus, Luke just told us again, that's 6.28. Times my radius, which is 6.5. Times my height. Okay, if you had this one on MCAS, they would not expect you to do this by hand. Okay, this would be a calculator question. Okay, 6.28 times 42.25 gives me 265.33. 6.28. Well, you know what? Let's multiply 6.28 times 6.5. Let's do that. Okay, it's 6.5. Okay, what would I do next to get h by itself? Yeah. Yeah, just going to take that 265.334, move it to the other side. Okay, so take 529.19 minus 265.334. 263.856. And 40.82 still on the other side. What's my last step? Divide by what? Yep. Okay, so we get a radius of about or height of 6.5. Just a coincidence that it came out the same as the radius. Okay, let's go back, make sure we put the right label on it. Okay, so see the labels I was using, centimeters, square centimeters. What should be the label on 6.5? Why not centimeters squared? Centimeters is correct.
It's not the radius or the diameter.
Radius or diameter would still have a label of centimeters. Why not centimeters squared? Yeah.
It's not measuring the area.
Yeah, it's not measuring area. Okay? Height is not area. Height is one-dimensional. It's just a measurement of length. So, perfect. Okay. Any question on that? Okay, so that's how you find your surface area of prisms and cylinders. All right, so the homework is mostly just using that one formula. It's on 732. Okay, try 13 through 27 all. Okay, 29, 32 to 36, just the evens. 42 to 48. 42 and 48, sorry. Okay, and because there's MCAS, I'm not going to give you an extra packet to do this week. Okay, we'll stop that. Okay, I'm also going to skip the test this week. We'll hold off on that.